Hey guys, what's up? Today we're going to talk about hypothesis testing for proportions. So let's go ahead and begin. Here's a problem. 20 years ago, 58% of the deer at Shawnee State Park were found as doe, female deer, doe remi. A study was performed to see if that proportion has changed. Of the 200 deer tagged, they found that 120 were doe. Okay, so they wanted to see if it changed. Well, let's write a null hypothesis for what we're dealing with. Okay, so our null hypothesis, I'm just going to abbreviate, is HO. P equals 0.58. Now, the alternative hypothesis, not at, the alternative hypothesis, okay, so H of A would be that, well, if it's changed, it didn't mention, is it greater or is it less than what it used to be? So in this case, it's just not equal to 58% or 0.58. Now, since we're dealing with a not equal, we're going to run a two-tailed test. All right. So let's get all our numbers in place here. So what do we have in the problem? Okay, this was our sample size. I could have used a different color. This is our sample size, 200. Okay, this is going to be X, 120. So I'll write X equals 120, and my sample size is 200. Now, I'm going to get on the graphing calculator here and show you a cool little feature on here. What you want to do is we're going to go to Stat, scroll over to Test, and what we're going to want to do is we're going to do a 1 prop Z test. So you can hit 5 on the calculator and it takes you right to it. Now it's going to ask you to enter in some data. Alright. Okay, P0, P naught. Okay. That's the same thing as what we have right here. H naught, 0.58. So I'm going to punch that in. So I'll go 0.58. Then we'll scroll down. Okay, my X, what did we say X was? 120. So I'm going to punch in 120 here. 120. And then my sample size was 200. Now we're just checking to see if it does not equal, so we want to make sure this is highlighted. Okay, then we'll scroll on down and go to calculate and then hit enter. Okay, so here's some pieces of information. It gives us a Z-score. Let me go to a different color again. Let's go green. Gives us a Z, which is 0.573. A P, which is 0.566 roughly, and then a P hat of 0.6. Alright, now that we have this information, okay, we need to check first to see if this is going to be a normal distribution model. Could it be normally distributed? So to check that, we're going to do N times P and N times Q. And I want to check to see if both N times P and N times Q are both greater than 5. If they are, I know then I can use a normal distribution model. So let's go 200 times 0.58. That's definitely going to be greater than 5. Okay, now let's go ahead and check N times Q. So we got 200 times 0.42. Okay, that's also greater than 5. So I know that I can use a normal model. All right, so let's go back to this and draw a picture. So I want to draw my nice looking bell curve here. I know. And we have this in the middle. Now here's one thing that we need to go back to the original problem for. We gotta use alpha equals 0.05. Now the z-score of that, okay, basically, and this is a two-tailed test, we got 1 minus 0.05, which is 0.95, and a two-tailed test, the z-score is going to be 1.96. Okay, so what that tells us is this is our boundaries. We got negative 1.96 here and 1.96 here. Now, nice looking model here, I'm telling you. In between, if the z-score that we calculate is in between this boundary, we're going to end up failing to reject the null hypothesis. Now, if it's out in this boundary here, now we're into the rejection region. Okay. Now, what did we have? So what did we have for z-score? Well, we had 0.573. Well, that's about right in here. Somewhere. I can't even pinpoint it. So I'm in that region. If I'm in that region, I'm going to fail to reject my null hypothesis. Okay, so we're going to fail to reject the null hypothesis. Now, if we ended up with a z-score that was like 2.4, somewhere around in there, in that shaded region, that tail, we would have to reject our null hypothesis. Now, there's another way of looking at this too. If we look at the p-values, okay, our p that we ended up with on the calculator was 0.566. Well, that is so much greater than what we were using for an alpha. Okay, so what that indicates, there's a great chance that we're going to end up with this proportion, or it's going to stay within that 0.58, at 58% proportion there. So as a conclusion, how do we really want to write this without sounding too redneck? Our conclusion is that we're going to fail to reject the null hypothesis, okay, the HO. There is statistically, this is where it gets scary because I'm going to sound smart here, statistically significant evidence to show the proportion, I should say state, the proportion of dough Getting carried away here. At Shawnee State Park has not changed in 20 years. Alright. Alright guys, so this concludes the video for hypothesis testing for proportions. And until next time, take care of yourself. Rock out.